Alright, welcome to Mr. O'Loughlin's math class on Lesson 91, Effects of Scale Factors on Perimeter, Area, and Volume. Now, I know this is going to be a little bit different than our normal classroom lectures, but we're still going to go over the same information, and I'll still expect you to have all of this in your notes. Since it's a video, you'll be able to pause, go back, re-watch any section that's confusing to you. If you don't manage to get it all down in your notes at the rate at which I'm writing, you can always pause it, write down what I've got, and make sure that it's in your notebook. Now, to start us off, we're talking about the effect of scale factors on perimeter, area, and volume. Now, we've already sort of talked about this each individually. We just haven't talked about them all in a group. So remember that perimeter is a measure of distance. Now, as a measure of distance, scale factors, which apply a multiplier to your distances, to your dimensions, are going to affect the perimeter on a one-to-one basis. So our ratio for the perimeter is just going to be our scale factor. Now, the area, because it is a dimension times a dimension, and both dimensions are being multiplied by the scale factor, we're actually going to multiply by our scale factor squared. Now, the ratio for volumes, remember area could be length times width. This could be length times width times height, if we're talking about a rectangular prism. Here we have three sets of dimensions. Now each of these three dimensions is going to be multiplied by our scale factor. So our ratio for our volume is scale factor raised to a power of 3. Now, one thing that we can notice is that here we have our normal scale factor, our scale factor squared for area, and our scale factor cubed for volume. So a helpful hint of how to remember that is that our scale factor will have the same exponent as the unit of the shape. So, if we're talking about a dilation to a square, we would measure the area in square units. So our scale factor is squared. When we're talking about the volume of a cube, we would talk about cubic units, or units cubed. So our scale factor will be cubed. Now remember, you can always pause the video. If I'm moving too fast, you can always rewind the video, take it on back. Now, example 1 says Vince was asked to paint a mural near the park based on a painting. The mural was going to be 10 times as long and 10 times as wide as the painting. He bought 10 times as much paint. He ran out of paint too soon. Why did he run out of paint too soon? How much paint did he need? Well, first off, this example should seem very clear given our information we went over in this section. Now, notice that he's painting a mural. A mural is a very large painting on a wall or another big surface. Now, when you're painting, you're not just making a straight line around what you're drawing. It's not a perimeter. You're painting everything inside. So it's an area. Here, if we have the mural be 10 times as long and 10 times as wide, our scale factor is 10. But we're talking about a ratio of an area. The area of the smaller painting to the area of the mural. So we're going to have to do 10 squared. So when we find that out, 10 squared is 10 times 10, or 100 times. That means he ran out of paint because he only considered the length, or he only considered the width change, but he did not consider the change as an area. How much paint did he need? He needed 100 times. As much paint. Alright. Example 2 says Irene works with stained glass. She wants to make a replica of a stained glass window. Her replica will be related to the original window by a scale factor of 1/3. The original window is made out of 3,456 square inches of glass and has a perimeter of 240 inches. How much glass will Irene use in the replica? What will be the perimeter of her replica? Now, I wrote down in our notes that she is making a 1/3, which is our scale factor, replica of a stained glass window. The original area is 3,456 square inches. The original perimeter is 240 inches. Now, we need to know how much glass will she use and what will the perimeter be. Now, how much glass will she use is a question of area. So, we need to multiply the original by our scale factor squared. Because remember, the ratio of area is the scale factor squared. Because we use square units, we're using a squared scale factor. So, we're going to take 3,456 and we're going to multiply that by 1/3 squared. Now, 3,456 times 1/3 squared is going to be 3,456 times 1/9, because 1 squared is 1, and 3 squared is 9. Now, our next step, remember that when we are multiplying by a fraction, we multiply by the numerator and we divide by the denominator. So we're going to take 3,456 times 1, which is just 3,456. And then we're going to divide that by the denominator, 9. So we're going to have 9 is dividing 3,456. Now, 9 cannot go into 3. 9 can go into 34 3 times. That's 27. When we subtract that, we'll get 7. We'll bring down a 5. And 9 can go into 75 8 times. 8 times would be 72, which would give us a remainder of 36. 9 can go into 36 4 times. So, our answer is that she would use 384 square inches of glass. Now, what would the perimeter be? The perimeter is not an area. The perimeter has a ratio that is equal to the scale factor. So we have 240 times 1/3. Now, 1/3 of 240 is just 80. However, our units for the perimeter were inches, so our answer will be in inches. Alright. Make sure that if you need to get the rest of this down, you pause the video. Make sure you have these examples in your notes. I'm going to be turning the page in just one moment. Alright, so example 3 says Nelson built this figure with 4 1-inch cubes. How many 1-inch cubes are needed to build a similar figure if the dimensions are doubled? Now, I'm going to draw the cubes that he has in his drawing. So in the book, we've got a cube here sticking out we have a cube sticking off to the side. Now remember, with these, we want to be able to approximate where our boxes are. If we can't visualize where they are, we just need to make sure we've got a close picture to what's in the book. Now, here we've got 4 1-inch cubes. Now, I know this looks like 3 1-inch cubes, but remember that behind these 3, there's 1 in the bottom corner. Now, if we're talking about making things out of cubes, we're talking about cubic units or volume. So remember that when our dimensions are doubled means times 2. Our volume has to be equal to a scale factor of doubled times 2, and since volume is cubic units, cubed. So, we would say that our original volume, 4, would have to be multiplied by 2 to the power of 3. Now, 2 to the power of 3 means 2 times 2 times 2, which is 8. So we would write 4 times 8. And that would give us 32. And these are 1-inch cubes, so 32 cubic inches. Or 32 cubes. Alright. And now remember that our dimensions is our scale factor. Our volume is going to be based off of that same dimensional scale factor. It's just going to be cubed. Alrighty. If you have any questions about this lesson, there will be another video with the practice set. Make sure you watch that. You don't need to have the practice set in your notes, but seeing those extra examples worked out will be helpful.